today we get to continue with our inverse discussion that we've been having in this chapter 5 section 1. So this is like the last little section in 5.1 for talking about inverses. So we're going to look at some inverses, be able to justify them algebraically, which we've been working on. Thinking of that idea of switching those x and y values, right, has to do with it algebraically. And then if we take a function and its inverse and we put them together, like what happens by doing those composition functions, see if we can notice any little patterns going on. So 5.1.3, what can I do with inverses? I can inverse them. So we're going to find inverses and we're going to justify them algebraically. So they even they give us this little puzzle piece that we're working on, and they always give us cute little clues when they do this. And you have like the original function, and then this one was like the inverse function. And remember that identity line, that y equals x? Woo, right? That went through there. It actually reflects it over there, so it gives you a cute little example of what an inverse looks like. They want us to look at this table on the right. So our table on the right has some x and y coordinates. If we think of inputs and outputs, x is our input, y is our output. Yes, exactly. So back in the day in first semester, we could look at tables and we could try and come up with an equation for those. We either did like arithmetic or geometric. Remember those a little bit? So to figure out if it's arithmetic or geometric, we had to figure out on our outputs if we're adding and subtracting or if we're multiplying and dividing. So if I go from -3 to 7, what do you think I'm doing? Or sorry, I apologize. Yes, -5 to 7. Yeah, how much are we adding?
12. Is it not 12?
12? Yep.
You're adding 6.
Well, hold on, we're getting there, yep. To get from 7 to 19, what are we doing? Adding 12. To get from 19 to 31, what are we doing? Yeah, we're kind of like adding 12, right? Uh-oh, I guess I can't write in white, right? So plus 12, to get to here is plus 12. So if we are adding, is that arithmetic or geometric? Arithmetic, yep. So when it came to finding our little equations for those, we can have like f of x equals, we're just going to do like cx plus a sub 0. Where c, oops, I like different colors. C is that common difference. All right, how did we get from one term to the next? And then a sub 0 is our 0 term, right? Coming back to you a little bit. So when we look at our table, it looks like we are increasing every time by 12. But when we look at our x's, what's happening? We're going up by 2. This one's going up by 2. So when it comes to figuring out our common difference, we want to be able to only go up by 1. So if it took us 12 to go up by 2, how much to go up by 1? 6, right? Yep, and some of you guys caught that ahead of time, right? So f of x, so our common difference, how we get from one term to the next is 6, right? X is going to stay x because that's our term. And then we have to figure out our 0 term. So that means we have to do what? We got to go back. What happens if we go back? Well, if we subtract, yeah. Because to get to the 0, we're actually only going to subtract 6 from it, right? Because we only want to go back 1. So we're going to go back to -11. Yep. So -11. And then if we want to, we can just double check it to see if it works, right? Pick any one of our x's. So if we picked 3, And if we put 3 in there, 6 times 3 is 18. 18 minus 11 is 7, and we had 7. So, and we can try any of them, and it should all work out. Sound like a plan? You guys remember that goodness?
Mm-hmm.
All right. So that's coming up with the equation. So we're going to hold on to our little equation.
So then do you flip that?
We're going to, yeah, in just a second. Yep. When it comes to coming up with those inverses, we could look at our table, right?
Just flip those though? Why don't you just flip the x and y in the table?
Yeah, you can, right? So when it comes to the inverse, yep, you can just flip it in the table. So to make a table of the inverses, what are we going to do? We're going to flip our x's and y's, right? So we get what? Negative 5, 7, 19, and 31. 1, 3, 5, and 7, right? Not too shabby.
That's a stupid question.
How are they related to each other?
It's just
Yeah, they are flipped. You guys got it. Psst. Oh wait, matches that one. Yep. Isn't that crazy? We could hear it all the way up here. All right. So one thing you could do is you could take a table and you could flip your table, and then you could try and go through and write your inverse off of the table. Or we can go back to our equation. Remember our equation? What did we have? F of x equaled 6x minus 11. And we can flip it, right? So this is what? Y equals 6x minus 11. So what's the first thing we do? Flip the y and the x. Okay. So now we get x equals 6y minus 11. What do we want to do? Add 11. Yep. And then we're going to divide by 6. Alright. So sometimes it's easier to do this algebraically. I'm going to write this a little differently. I'm just going to separate my fraction out. So I'd have 1/6 x plus 11 over 6. Right? If we were to do it algebraically, right, that would be our inverse. So the inverse would be 1/6 x plus 11 over 6. Right? And sometimes it's easier to do these algebraically than looking just at the table. When I look at the table and I try to figure out my equation, all right, I know it's algebraically. I'm going up by 2's. All right, so I know that my common difference is 2, but when it comes to these guys are going up by 12, right? So then you almost have to divide this all out, right? So you're going up by 2's, but this is going up by 12's. So to figure out for one increment, you'd be dividing those guys out, right? So you're talking about a 1/6. So each time you change by 1, you're changing a 1/6, right? And that's where our common difference of that 1/6 came into play. And then you have to go back to the 0 term. So to get to the 0 term, whoops. Oh, to get back to the 0 term, you have to go back 4, but you have to go back like 4th, 6th. So you have to do all these mathematics with fractions and everything else. So looking at the table to come up with the original equation is sometimes easier. But then once you get to finding the inverse, depending on what the table looks like, I think it's sometimes just easier just to jump right to the algebra and go ahead and do it with the algebra as opposed to messing with all of those fractions. Makes sense? All right. We got a couple of these to do, and then we'll call it good. So these ones, they just want us to find the inverses algebraically. And I know we've been working on these, but we just want to throw a couple more examples up there. Right? So we started with y equals 2x minus 1 to the 3rd. And I think you guys have seen some of these on your previews and reviews, so First thing we always do when we want to solve them algebraically is to flip the x and y. Yep. Now what do we want to do? What do you think? Problem is you can't distribute that too. So because of orders of operations, your exponents would come first, right? So if you wanted to, before you could distribute, you would have to do that third. So that would be, you'd have 2 times y minus 1 times y minus 1 times y minus 1. And then you'd be multiplying all of that out. So when we're doing the inverses, we're almost doing the reverse of PEMDAS, right? So is there really anything we can add and subtract to the other side right now? No, because that's in that parentheses with that exponent on there, right? So then we're going to go to multiplying and dividing, right? Because we're going backwards. Is there anything that I can multiply and divide both sides by?
2.
Yeah, because that's technically multiplied, right? So then we're going to divide by 2 first. So we get x over 2 equals y minus 1 to the third. What's my next one I'm going to do? What's the E stand for? Exponents. Do I have an exponent?
Yes.
Yeah. Yep, it's to the third, right? So I'm going to take the third root on both sides. Okay. So it looks like a square root. Technically, when we do square roots, technically there's a 2 there. We just never put the 2 there, right? But now that we're taking the third root, we're going to throw the 3 in there. X over 2 equals the third root of y minus 1 to the third. So the left side's going to stay the same. And when I take the third root of something to the third power, I'm just left with what's in the parentheses, right? Y minus 1. And then now what can I do to get it all by itself? Add 1. And we're going to leave our problem just like that.
Is that x over 2 technically like 1/2 x or no?
Say again? Oh, yes, if you wanted to. Yep, you could. It would
I was
be.
just making
Yep, you could write it as like the third root of 1/2 x and then plus 1 on the upside. Yep, you could write it that way too. Yep, absolutely. All right. Not too shabby. You guys have been practicing these, right?
Yeah.
All right. All right. Let's run through this one real quick. All right. First thing we're going to do,
Subtract 3.
switch the x's and y's. Gotcha. No, you're fine. So x equals the square root of y minus 2 plus 3. I need to give you a second to write the problem down. So we're doing our PEMDAS in reverse order, right? Because we're undoing. So adding and subtract. Oh, sorry.
Nothing.
You sure?
Yeah, you're not too close.
Okay. So adding and subtracting. What's the first thing I can do?
Subtract 3.
Subtract 3 from both sides. Good job, good job.
And then you square it.
Yep.
But when you square it, does it go in parentheses?
The left side, yes.
X minus 3 like parentheses? and
Yep.
then square.
Yeah, because you have to square this whole entire side. Just like you are squaring this whole entire side.
So then when you add 2, you can't add 2 to the 3.
Right, yep, because you'd have x minus 3 squared equals y minus 2. Okay? Then you're going to add 2 to both sides. Yeah. See, you guys are ahead of me. Plus 2 equals y. And then I'm good with leaving it this way. It actually is now in graphing form for a quadratic, right? Or if we really wanted to be like overzealous, we could multiply that all out. Right, because we're at what? X minus 3 squared plus 2 equals y. If we wanted to get it in the most simplest form possible, we would do what? X minus 3 times x minus 3. We still got our plus 2 equals y. Right? Some of you, we can do the area. Yep. Either the area model. Yeah.
So would it be x squared? Why is x squared instead of 2x? Because it's x times it. And if it was 2x, it'd just be. Why? Yes.
Right. If there was a 2 out front, then it would be 2x. But this is x times x.
Yeah.
Yep.
You don't know what x is.
X squared. Right. Yep. And then you have negative 3x.
Plus,
Negative 3x, right? So minus 6x. And then negative 3 times negative 3 is plus 9. And then don't forget your plus 2 equals y.
x squared minus 6x plus 11.
Yeah. But you can't factor it, so, yeah. So that would be like the most simplest form of it, but, right? And we get the same answer if we did, oops, the area model, right? You feeling a little bit more confident on doing some of these? All right. Woo, look at this crazy one. I think this one will be our last one for the day. How's that? I just start doing these inverses and I just want to keep on chugging along. Don't you guys?
No.
Yes, yes, exactly.
No.
So if we're looking for inverse, first thing we always do?
Switch x and y.
Switch x and y.
Subtract 20.
Yep. Reverse order. Remember that, guys, right? If it helps, write that down and give yourself a little arrow, right? Adding and subtracting. We're going to subtract 20. Now we can look at multiplying and dividing. Is there anything we can multiply or divide out? The 3, yeah. Divide both sides by 3. Whoosh.
Can you leave it? Can you leave like the fraction?
Like that?
Yeah.
Well, we can keep working. We're not done yet. Wait a minute. Where did my y go? Come on, guys. You gotta...
It's 1 minus 9.
Yes. You guys are supposed to... I do this on purpose to see if you guys are paying attention. Actually, it's because I'm not perfect and I make mistakes all the time. This should have been all of our y's, right? We good now? All right. So anytime you have two fractions that are equal, they're proportionate, right? So that numerator times that denominator, or denominator times numerator, is going to equal that numerator times that denominator, right? So we call it cross multiplying. So we can cross multiply. Yep. Multiply those guys. We get what? 3 times, to get rid of the fraction. Right. Multiply these two guys together. 2 times x minus 20.
That just messed up my whole thing. Why can't you just keep going multiply by 2?
If you, well, oops, we'll do it over here.
Because you just get 2 parentheses
Right.
x minus 20 over 3.
But if I multiply this side by 2,
Yeah.
right? And then when I multiply this side by 2, this goes away, right?
Yeah, and then you y minus 9, and then you add 9. So it's 2 parentheses x minus 20 over 3 plus 9. Why is that wrong?
Well, you can keep simplifying, right? So 3y minus 27 equals 2x minus 40. Add 27. What happens when we add 27? Minus 13. Then they're going to divide by 3. So negative 2/3 x minus 13 over 3. And yours is it?
Well, it made more sense.
Yeah, but this one, so we got 2x minus 40 over 3 plus 9 equals y.
They're both.
So now you got 2x minus 40 over 3 plus 27 over 3 equals y. So then now you get 2x minus 13 over 3 equals y.
Why is it 27 over 3?
Because to add these, you got to have common denominator to add fractions.
Oh, so it's just See, yeah, it just made more sense.
Yep, that's fine. Yep, and you can either leave it that way or mine's just separated, right? 2x over 3 minus 13 over 3 equals y. Right, if you just separated them into two fractions.